Scientists presented a three-dimensional model of the height distribution of the upper cloud layers of Jupiter, created on the basis of images of the Juno station taken on July 5. They used images taken from a distance of 13,000 kilometers from the planet using a methane filter. The model was based on the idea that brighter cloud layers are better illuminated by the sun because they are at higher altitudes than darker cloud layers, which are better at absorbing and scattering light. Given that Juno moves on an inclined trajectory relative to the planet and has time to observe the same clouds from different angles of view, it is possible to estimate the height differences of cloud layers. In the future, scientists intend to refine their method for converting the Juno observations into physical models of the height distribution of the upper edge of the clouds in different regions of Jupiter's atmosphere, which will improve the theoretical three-dimensional models of their chemical composition.
Oh, wow.
Yeah. Oh my goodness. 8,
Yeah.
7, 6,
wow.
5, 4, 3, 2, 1.
NASA spacecraft collides with 160-meter asteroid. The success of the mission confirmed humanity's ability to send spacecraft to collide with asteroids in order to protect Earth from their effects. After a 10-month mission, NASA's Double Asteroid Redirection Test spacecraft made a controlled collision with the 160-meter asteroid Dimorph, which is part of a double system, along with the 780-meter asteroid Didymos at 2:14 a.m. Moscow time on September 27, 2022. In the future, the mission team will use ground-based telescopes to track the movement of Dimorph around Didymos in order to check the calculated predictions. As a result of the collision, the orbital velocity of the asteroid moon should decrease by about 0.4 millimeters per second, reducing the orbital period by 10 minutes. The collision was done head-on at 22,500 kilometers per hour, so even though there was a significant difference in mass 550 kilograms versus an estimated 3 million tons, the impact was noticeable. It is believed that even a small impact on a potentially dangerous object at a distance of millions of kilometers from Earth gives a large change in its trajectory, which in the future may allow to secure our planet from a possible disaster. The James Webb Telescope has sent the first photos of Mars. The close-up on the left shows surface objects such as Huygens crater, the dark volcanic Syrtis Major, and the Hellas Basin, while the heat map on the right shows the light given off by Mars as it loses heat. Elon Musk is already scoping out a site for a city. Planetary scale heat wave detected in Jupiter's atmosphere, a heat wave with a temperature of about 700 degrees Celsius. It extends 130,000 kilometers, 10 Earth diameters. Jupiter's atmosphere, known for its characteristic multicolored swirls, is quite hot. Jupiter's upper atmosphere should theoretically be cold, and its temperature should be about 70 degrees Celsius. However, the cloud tops of Jupiter have a temperature of over 400 degrees Celsius. Polar lights exist at the poles of Jupiter. They are constant and have variable intensity. Powerful auroras can heat the region around the poles above 700 degrees Celsius, and global winds can redistribute heat across the planet. The heat wave was probably caused by a pulse of solar wind plasma affecting Jupiter's magnetic field. The impact probably intensified the polar lights and caused the hot gases to expand and splash out toward the equator.